So good morning everyone. Just for your knowledge, as we have participants from Canada team as well, so this meeting is going to be recorded. And good morning Cliff, and good morning everyone in India, and a good evening to the attendees in Canada. I am Dhwani Batish, and currently I am an event manager at Chitkara Analytics Club, and I'm very excited to welcome you all to join in as to explore the fascinating world of
Oh, I think she's breaking up
that
for
he is
me.
eager to. Without any further ado, I'm pleased to hand it over to
Dhwani,
Cliff.
hi. So
Yes.
you weren't audible at all, I feel. Was it just me?
Oh yeah, it
Okay,
was breaking up for
You
me as
were
well a
not
bit.
on.
Yeah.
so may I just start again? Now I'm audible?
Yes, you are.
Yes.
Okay. So good morning everyone, and good morning Cliff, and good morning to people in India, and a good evening to the people attending from Canada. I am Dhwani, and I am currently an event manager at Analytics Club Chitkara, and I'm very excited to welcome you all to join as we explore the fascinating world of analytics and data. So today we are honored to have a special guest, Cliff, who is very expert and brings a wealth of experience to our discussion. He's a renowned data expert and an analytics consultant, and his hands on experience in fraud detection and his role as a senior data risk manager at Grab, which is a leading mobile technology based company in Singapore, has equipped him with unique insights and practical knowledge that he is eager to share with us. And without further ado, I would like to hand it over to Cliff so that he can proceed with the speaker session.
Thanks, Davini, I think. Sorry, bad pronunciation. Okay. Thanks everybody for coming today. I know it's a pretty international crowd, I guess, like quite a few people. So, without further ado, let me dive in. So this is the topic for today. In particular, I always feel that it's a bit interesting in this topic of fraud analytics because it's not so commonly shared. So hopefully today's sharing will be a bit more insightful in terms of not just analytics, but how analytics is applied to a specific domain under fraud detection. Okay, so a bit about me, which is what I'll cover later, and this is just some of the things that I'll cover today. In particular, we'll be going deeper into like a lot of things relating to fraud and how analytics kind of support fraud detection and how we at Grab does it at a corporate and like corporate level. Yeah. So let me move on. Okay. So a bit about me. I actually didn't graduate with a technical degree. So I actually had a master's from NUS, National University of Singapore, in economics. So I usually kind of like gloss over my first few jobs because it's a bit boring. I kind of got my first more technical role at this company called Carousel. So it's kind of like the mobile eBay where you can like buy and sell we call pre-loved items and stuff. So I was there for 3 years. After that, I was fortunate enough to actually enter Grab. So Grab is like the Uber of Southeast Asia. So basically they're trying to do quite a lot of things now. They include like ride hailing, food deliveries and stuff like that. So in particular, I was in the fraud team. That's where I got to know Seria. So Grab is really, very, very, very big team. And in particular, people will be curious, like, oh, what kind of fraud we're dealing with? So I'll explain a bit more later. But in particular, because The idea is that for companies like Grab, and actually any kind of like tech company in the past 10 years, right? When they want to get new users, we will provide a lot of incentives. So we're going to have enough supply of drivers, enough supply of consumers. So because of this like incentive driven kind of approach to growing the business, there's a lot of like gaming behavior where people are trying to kind of like, you can imagine like abusing some of our promotions or trying to abuse some of the incentives that you can get as drivers on our platform. Yeah. So that I'll be sharing a lot more on that later on. So right now I'm actually an analytics freelancer. I've been doing that for I think 3 years ish. It's kind of interesting to kind of leave a larger company to kind of help like more traditional companies who have data but are not really sure how to utilize them to kind of better make like value, to try to kind of create value of their own like current data that they have right now. So it's pretty interesting. Yeah. So that's my current journey so far. Okay. So moving on. So when I look at certain topics, I actually kind of like to think from first principles, because I think from there, you can kind of like think about what are the next steps, what are things that are important and stuff. And in particular, when you're dealing with we just call them bad actors. Basically people who are doing stuff that we don't want to do on our platform. It's a bit tricky because they won't tell you what they are gonna do. So a lot of times you kind of have to think through about the different processes when you're dealing with like bad behavior. Okay. I mean, here are some of the first principles that I kind of managed to kind of like gain within my 2 years plus at Grab. And a lot of times, the first principle is what we call the money trail. So very important, right? In the sense that at the end of the day, fraudsters, scammers, they're looking at getting money, right? So a lot of times, the approach might not be very direct, at least not very direct to us. A lot of times you have to think through, okay, why is such behavior happening on our platform? Of course, in particular, will be certain undesirable behavior. And if so, how does the fraudster or the scammer gain from doing this kind of abnormal behavior? So a lot of times you kind of always have to link it back to how are the fraudsters like gaining from this. So that's the first principle here. Second principle here is kind of seeing them as identifying bad accounts versus bad behavior. So a more specific example would be that when you're thinking about like fraud or like gaming behavior, like people who are like trying to abuse the platform, there's always syndicate level and there's like non-syndicate level. So you can imagine like me figuring out, hey, maybe this platform is giving promotions, but for some reason, I can always create new accounts and kind of get these like new promotions. So it's not really industrial, like I'm not really a syndicate, but I just found kind of like a bug on the platform. Versus like real syndicates who are actually doing this at scale. Maybe they are like hiring like computer programmers, building bots and doing stuff at a much larger scale. So a lot of times you kind of have to think from identifying both the bad accounts and just identifying bad behavior. And that can be a bit more nuanced when you're looking into fraud itself. The third point here is that because of the nature of fraud detection, we actually kind of do split it up between detection and enforcement. And this is kind of linking up to false positive and false negative, which I can kind of combine together. In a sense that we are always mindful that when we are looking at fraud, right, there's always the opportunity, there's always this probability that, hey, maybe me calling a particular account fraudulent could be actually a wrong call. In the sense that I'm actually, like based on data, right, there's always some kind of error here and there. So we are always very mindful that firstly, when we are doing detection, it is us indicating, hey, we got signals that this account is doing malicious behavior. And of course, after that, what kind of enforcement do we want to kind of proceed with? There's a lot of different enforcements that I can mention later on. But it is important to kind of understand this difference between detection and enforcement. Yeah. And also, I mentioned briefly about like false positive and false negatives. So the simple way of explaining is just again me saying somebody is doing fraud, but actually he isn't. So in a sense that it's kind of a negative side effect where if we are too stringent on our fraud detections and enforcements, we could actually lead to a lot of negative user experience for people who are not doing fraud. So imagine you are just doing your own stuff on the platform. Suddenly your account got blocked. Suddenly your e-wallet gets like locked. And it's like, hey, what's happening here? Come on, like I'm just a normal user. And we get complaints, we get people who stop using our app, uninstall our app and stuff like that. So we do know that actually as the fraud detection team, we are kind of having a very fine balance between protecting our users and ensuring that we don't give them a very bad user experience. So that's a fine balance that it's not just something that we can say, oh, it's okay, it's just part of the error in the model and stuff like that. Because it does really affect our user experience at the end of the day. Yeah. Last but not least here, in particular, I think compared to other more traditional analytics domains, it's a bit trickier because it's kind of the funny thing that we always say, like in fraud, right? Nobody comes in and say, hey, I'm a fraudster. So a lot of times we actually kind of had to deal with unlabeled data. And imagine looking at very traditional kind of like frameworks where you're looking at e-commerce or churn predictions, predicting pricing and stuff like that. A lot of times when you're dealing with those domains, you have very clear specific labeled models, users who have churned, users who are not like who are still active and stuff like that. But again, fraud is always very, very difficult to kind of label. We do have certain ways to kind of define, say, hey, these are with very high certainty that these are labeled fraud behavior, but it's still again based on our own judgment. So again, it goes back to us being how confident we are in being certain that hey, these are fraudulent accounts, fraudulent behavior, and we're kind of labeling them. But we're always mindful because again, we don't want to provide bad user experience by blocking users who are legit. While we also want to ensure that we're not losing too much incentive to users who are just like trying to scam us out of our funds and stuff like that. Okay, so these are our general principles dealing with fraud, and I think these are some of the key principles that I think it's pretty unique to fraud itself. And I think one interesting thing is that when people go into different domains, it's always good to kind of think through what are the first principles within your domain. And in a way, it kind of help you to be a bit more robust in your approach to some of the new things that might appear in your specific domain, regardless if it's fraud or not. So moving on. Okay. So I'll go more specific into fraud at Grab itself because I always feel context is very important. So Grab is actually a very, very large company. So we primarily have, I'll just primarily say we have like a few verticals. So we have ride hailing, we have food delivery, and we have parcel deliveries. So I would say it's just either you're moving people, moving food, or moving goods in that sense. So for me, I was actually dealing with fraud detection in transport, but I can see that these are all the more general kind of stuff. So again, first principles, right? When you're saying it's dealing with bad behavior and bad actors, because when you're dealing with, although I put the term fraud, our team actually deals with a lot of other bad behavior. So you can think of, say, like drivers who are speeding. So that is considered bad behavior, even though it's not fraud, because it can lead to actually very like bad user experience if our passengers like are very fearful of their lives and stuff. So that's one. And unfortunately, there are certain markets that are a bit more dangerous in the sense that we have drivers who are like stealing from the passengers, or even unfortunately some like rape cases and stuff like that. So all these are considered bad behavior when you're dealing with fraud in general at Grab. And for us, at least for my team, I was just purely looking at ride-hailing kind of fraud. So again, wanting to ensure that our platform not losing too much money to particular fraudulent activities. And again, also to ensure that we don't have such strict detections and enforcements that causes a negative experience to our users. And these are general principles. So these are some of the angles that we are looking at. So the first angle is kind of looking at user to platform, meaning users who are trying to game our system and like, I would say just like fraud, particularly gain money from Grab itself. So things like incentive gaming, feature abuse, and user collusion. So there's many different scenarios, but a lot of times it's about how users are trying to unreasonably gain incentives from Grab, because maybe we could be giving incentives for additional completed rides, or if a particular user is using certain features that we're trying to push, we might give incentives as well. So a lot of times we want to ensure that these are actually given to the rightful users and not people who are just using some way to just kind of gain incentives from us. So the first level is user to platform. We also do have quite a few behavior that are looking at user to user. So some issues are things like account takeover, illegitimate service provision, and safety breaches. So some of the cases of account takeover were things like when we first had our e-wallet feature, unfortunately there were certain users whose e-wallet account got taken, they got hacked, and then they had their money like withdrawn and then sent to another account. So stuff like that. So although from a Grab perspective, we are not losing money to this fraudulent behavior, but it's still harming our users on our platform, giving them a very bad experience. So from a detection perspective, we were also still looking at some of these user-to-user kind of like fraudulent behavior. So these are just some of the things that we're looking at Grab when dealing with fraud. Okay, so moving on. Okay. After going through all the general stuff, I'll go specifically to how we work as a team in Grab when dealing with fraud. So in particular, it's really working as a team. And it's really a huge team effort, and everybody plays a part. So these are some of the different people involved. So I primarily was working as a data analyst. So a lot of the things that we're looking at were all rule-based. So we have data scientists as well who are looking at more model-based kind of detections. And we kind of complement each other. I'll explain a bit more later on as I go through all this. So we have risk operators as well. I think this is the term that I should call them. I always can't remember what's the exact term. But these are basically people who are on the ground, who are more linked to some of the policies that are involved. And they're people who kind of are the counterbalance to some of our rules. The thing is that as data analysts and data scientists, we try to be a bit more neutral in the sense that how we see things is basically just through data. But again, there could be false positives. There could be new things that are coming from the local markets that we don't know. So a lot of time, these risk operators actually help provide us with certain local knowledge or certain things that they see on the ground. It could be increase in complaints from drivers about certain enforcements, like, hey, why are we seeing a spike in certain like e-wallet being locked and stuff like that. So the risk operators kind of give us the eyes on the ground. We also have data engineers who kind of help provide us timely and quality data. In particular, imagine companies like Grab, right? Like we have like, I think hundreds and millions of users across different markets. So a lot of times when we are looking at certain detection mechanisms, we do need data engineers to kind of help us with cleaning up the data, processing them so that we can actually analyze them from a different data marts that we build for ourselves. And it's to the level where it's not just with data engineers. We do have infrastructure engineers as well who help us with specific real-time detections. In particular, it's to ensure that it's not just detecting fraud when it's happened, but sometimes it's to ensure that, hey, we are seeing certain things that are happening. We are not going to let that user perform any other action. So we're going to block that user so that we are kind of like really stopping fraud before it's happening in that sense. So for that to happen, we really have to work with infrastructure engineers to kind of implement some of this detection and enforcement mechanisms into our platform so that it happens in real time. For here, maybe I can explain a bit more between the difference between data analysts and data scientists. Although later on, I think I have some slides as well. Yeah, I think maybe I should just go on to that part instead. Maybe clearer. Okay, I'll explain that later. So for this slide here, I'm just covering more in terms of what my team does in the analytics team. In particular, there's like data scientists and stuff like that. I'll explain a bit more later on that. So specifically for me, I kind of split them into three main parts. And I do think that this is pretty similar kind of framework for some of the other roles that I've been involved in, particularly looking at data, engineering, and alignment. So these three buckets here. So data is typically what you see and what you kind of expect when you're in a data role. Particularly what are some of the things that we would learn in school, right? So like creating dashboards to kind of track certain matrices, provide certain ad hoc data requests. If let's say we see a particular issue, it's like, hey, I think we are seeing some new things happening on the ground. Can you do a query that looks at particular drivers in a particular market performing certain actions? And we'll be like, hey, yeah, they seem to be getting abnormal amount of incentives for certain reasons, stuff like that. And of course, doing deep dives as well. So a lot of all this kind of work is dealing with data, SQL, using Python, creating dashboards and stuff. What you expect from a data analyst. In the middle portion here, which I kind of see as the link between data and alignment, which I'll explain a bit more. So for data engineering, a lot of times, because of the nature of fraud, we actually kind of have to appreciate like how certain data points are being created. Kind of understand, hey, like, is the data coming in a way that we can maybe do certain enforcements in real time? Or is there any way that we can maybe get more information? So things like, there was an interesting phase in my time at Grab where there iOS 15, I think. And that actually affected a bit of our detection because of privacy issues. Apple wasn't willing to give certain information about certain iPhone models because of privacy. And that actually unfortunately hindered some of our detection mechanisms because like, hey, we were using those IDs or those information to make certain predictions as well and stuff like that. So because of that, we had to kind of figure out, hey, because we couldn't do certain data tracking anymore, certain rules had to be changed, or we had to be more loose or more strict on certain criteria and stuff like that. So beyond just doing data itself, we kind of actually have to appreciate how data comes into us, work with engineers to kind of see, hey, can we get more information about certain users and stuff, and just kind of really see from there how we can make more detection mechanisms and enforcement and stuff. So that part is engineering. And the last bit, actually, I feel is the bit that is actually the most important part. In a sense that because it's the part where we kind of translate engineering and data to actual value to the company. Because at the end of the day, you can have the best model, you can have the timeliest data, but if it doesn't solve an actual problem, technically there's no value to it. And again, I think this is something that's very important when you're dealing with any kind of domain, to really understand what your domain's value is. So naturally for fraud, right, it's just to detect bad actors, to ensure that Grab isn't losing too much money to some of these fraudsters. So a lot of times it's actually about defining problem statements, in particular refining some of the statements that our stakeholders have, to be actual. Sometimes it's even as concrete as an actual SQL statement. So things like, hey, we are seeing users abusing a particular feature. They're using too much of it and then gaining too much incentive, whatever. Things like that. Okay, maybe I can be a bit more specific here. So one example is, let's say, put yourself in the shoes of a food delivery person. How many meals can you deliver a day? Physically, like in a real actual sense, maybe 30, 35, 40. There will be a maximum level, right? Like maybe you can say 100. That could be the max. So a lot of times when you're saying, hey, how do we detect bots who are actually just making fake deliveries versus actual people who are making real deliveries, we will kind of say, hey, maybe we see the upper limit as 50, because above 50 is humanly impossible. Nobody can deliver more than 50 meals a day within real physics in that sense. So the problem statement could be that, hey, we want to detect potential bots. And from a data standpoint, you'd be like, okay, I will have these data points. And I kind of say that, hey, maybe I would set a rule that says that for any user who has delivered 50 or more meals, there's a chance that this user could be a bot. It could be a fake account and stuff. So it's about understanding the problem statement, aligning with your stakeholders around here, and kind of say, hey, so now I have an actionable rule, which means that if I see any user doing more than 100 deliveries, I will have a detection mechanism that says that, hey, this is potential fraud. We will think about it. We might need to do some enforcement and stuff. So that's the part about the defining the statements, thinking about what are the possible new features based on maybe new product features that are coming out, how I can detect fraud from these new data points that I have. And of course, actually aligning with enforcement team to say, hey, now we are seeing a lot of new detection. We have this new rule that are detecting certain behavior, and we do see quite a few people hitting this rule. Means that our rules have detected quite a large number of users who are performing these actions that we deem are actually fraudulent. And of course, from there on, we will say, hey, there's a few things that we can do. We can ban the account, we can ban the action, so on and so forth. And again, of course, this is alignment with the risk ops team, because they will be the people kind of dealing with any customer complaints about false positives and stuff. So beyond just working with our fraud, like product managers, to ensure that we are actually ensuring there's not so much fraud happening, we also have to kind of align with the risk ops people to ensure that we are not kind of being too strict and then causing a lot of negative sentiment about our platform, blocking people for no reason. Yeah. The last bit here as well, because we do have a data science team who are doing more sophisticated modeling to kind of detect fraudulent behavior, we also have to align some of our rules, our detection rules with them. So we kind of see ourselves as a counterbalance of each other. Not in the sense that we are like against each other, but it's more of like we are a health check. So an example is that if we have a new fraud model that came out from a team, we will always check to ensure that, hey, is this fraud model having detections that overlap a lot with our existing rules? And it's kind of it's bad if it's too extreme. Meaning that if this model has a lot of coverage, meaning it's detecting a lot of new behavior, it could be a good thing, but it could also be that actually all these new detections were actually false positives. On the other hand, if the new model is actually overlapping with a lot of existing rules, it could mean that this new model maybe isn't worth the time deploying it into production, because technically it's not giving us much more new detection uh, accounts in that sense. Like it's not detecting a lot of new accounts. So it's a kind of fine balance in that sense. And a lot of times we work with the data science team to kind of understand how their model is improving. Are we seeing a lot of issues with fault policies and stuff like that? So although I didn't really get to do a lot of modeling in that sense, but I still had to work with our data science team to kind of understand some of the models, understand the intuitions. And a lot of times we actually do feed like each other with a lot of different inputs of what we have seen on the ground or some new data points that we get from our data engineers and stuff. Okay. So this is generally how these are the general tasks that we get to deal with as data analysts in Grab. Okay. So to be a bit more specific, these are some of the what I kind of will focus on in terms of the skills that you kind of need to be a data analyst when you're dealing with fraud. This shouldn't be something that's very new to you guys. If you guys are already like dealing with data, right? So Python for data exploration and automation, in particular, if you're doing some kind of like automation, Python is kind of like the key thing that we use. SQL in particular for data extraction. Because of the large scale volume of data that we're dealing with, we kind of really need SQL to kind of scale across all different data sets, just for like ease of data extraction. So Python and SQL is a must. But of course, a lot of times when you're actually presenting our findings, ensuring that we have certain matrices that we are tracking on a weekly or daily basis, we still have to kind of create all our matrices into particular Tableau dashboards. And usually these are kind of like the key references that we use to discuss our conversations, have our conversations with our stakeholders, with our PMs, so that like it's not just us dealing with data in SQL and Python. We do have to share this with our stakeholders, so that we have like common ground, kind of understand, hey, our matrices are trending down, trending up. What are some things that we need to take note of and stuff like that. Yeah, so kind of using Tableau is kind of like the main thing that we can do as well. So these are the bit more technical stuff. Tableau, I would say, is a mix of technical and non-technical, so sharing with our product managers and stuff. These two last points here, I would say I can't emphasize them more. In particular for domain knowledge, with reference to a point that I shared just now, your model can be as good, your data can be as good, but if there's no domain knowledge to what you're doing, it's a very high chance that you might not get the value that your team needs to get from you. When you're looking at detection, be it like fraud detection, detecting risky behavior and stuff like that. So it's actually very important to kind of understand what your product manager wants you to look at. And in particular at times, and say, hey, I have this data set. Maybe I can help you get a certain proxy detection or estimation on certain thing that we're discussing. Does that make sense? And you really kind of have to dive deep into the domain. So as we're dealing with fraud, I remember I had to kind of go a bit deeper into things that were a bit more towards like hacking in that sense, because we had users who were like jailbreaking our apps and sending us weird data sets to kind of mask their behavior. So we had stuff like that as well. So I had to actually work with really our cybersecurity team to understand, hey, do we have ways to kind of consume certain information from our app and kind of detect and kind of allow us to make certain detections. So domain knowledge, I think, is really important. Last but not least here, I would want to emphasize as well is soft skills. In particular for domains that are very technical. A lot of times, maybe not all our stakeholders are so attuned to some of the domain situations that we have. So in particular for fraud, because we had to deal with like kind of like cybersecurity stuff as well, it's really kind of important to kind of understand, hey, is the issue happening with data? Is the issue happening with product? Maybe it's just our product team are not being very mindful of certain things. Maybe you just need to set certain limits to how much a person can use a particular feature and stuff. So a lot of times it's really about communicating what we see from a data perspective to our product managers. And really, it's not just about dumping him information. Oh, from SQL, I got this, I got that. It's linking with the domain. It's understanding what value is required from our domain expertise, and really communicating from there and say, hey, from what I see from the data, I do see that there's like a high volume of people doing certain bad behavior that's causing this amount of damage to our platform and stuff like that. So at the end of the day, you can have the best technical skills. I feel that it's actually very important to understand what's the domain that is being applied to, and really being able to communicate what your technical expertise is actually getting out of from the domain. So I think all this is actually quite a good mix of like technical and non-technical skills. And in particular, it's pretty important for data analysts because you're always like kind of like working with engineers and domain experts here. Okay. So moving on. So I'll be diving a bit more deeper into some of the stuff that I mentioned just now. In particular here, I'm talking about the difference between the data science team and the data analytics team. I realized that when I do my sharings, this is a very common question, like, hey, do you do modeling? Like, what's the difference between the machine learning people versus analytics? So for me here, I kind of broken down into two major components. So machine learning solutions. So I understand that the team that was dealing with machine learning models, right? They were actually using PySpark for a lot of model training, in particular because it was very, very big data sets here. So you had to use PySpark for some of the scaling issues and stuff. So we did have some kind of labeled data sets that we kind of have to like handcraft, because it's like these are people or these are behavior that we are very certain that these are fraud, and we kind of labeled them. It was a very troublesome, like very, very laborious kind of like approach, but we still had to do it because we still wanted to have some kind of modeling approach to complement our rule-based kind of approach that I'll share more later. And basically the machine learning engineers will kind of build some of the models based on all these labeled fraud data that we have. But on the other hand, we also do have unlabeled data sets approaches. So let me click to share this here as well. You can see these, my ex-colleagues from Grab, as in they are still in Grab, like I'm not in Grab. So they had, this is actually a pretty old paper, and I understand that they are actually still having some developments here. I won't go too deep into this because it's pretty technical, but I can share the slides and all these links with you guys after the presentation is done. The general idea here is that they are mapping behavior through like a social graph. You can think of it as like Facebook in a sense. So the idea is that fraudsters, birds of a feather flock together. So fraudsters tend to kind of like have behavior that happens with each other, or they tend to like be near each other depending on how you define your data. So this approach is a bit challenging in that sense, but it's more robust as well because you don't require labeling data sets. It's just say, hey, we have a cluster of people who are doing particular behavior, and then after we maybe do a particular deep dive into this cluster of people, we realize, hey, they seem to be doing certain things that are actually like anomalous or like suspicious. Okay, so let me close this here as well. Let me go back to my side. Yeah, okay, here. Okay, I think I do this. Okay, but yeah, oops, something back here. Yeah. So that's for network graph detection. So you can see that some of the things that they're dealing with, right, are a bit more they are much more machine learning based. Whereas for my team, we deal with more rule-based kind of stuff, domain-specific detections. The thing about my team is that because there's a lot of data sets we kind of deal with, right? So a lot of times, actually, there's some simple rules that we can kind of really craft. They are pretty intuitive. So the example that I shared just now was the physical limitation of a food delivery person, right? Like you can only deliver 50 meals a day max. Stuff like that. So of course there's a lot of different rules which I can't remember. I think we had like 100 over rules based on different kind of mechanism because we really had a lot of data points. And just now the example that I shared is a very simple rule. We do have rules that are made up by a composition of rules as well. It's just to ensure that we don't hit false positives. And we are always mindful of like new data sets or new features. So one example that I remember is that because there was a new algorithm that allowed our food delivery people to what we call batch deliveries. Meaning in the past it was a very inefficient algorithm. It was okay, we have a meal request, we have one food delivery person, we will get this food delivery person to make one food delivery. That's it. But because there were changes to the algorithm, our back-end engineers were more able to efficiently allocate, say, hey, because we had like 4 requests of meals within a certain area, and the restaurants were all in another place that's very near as well, we could get this one food delivery person to deliver 4 meals in one trip trip in that sense. Because our algorithms got more efficient, we had to also change our threshold. I remember, I think initially we had a lot of issues like, hey, how come we have more and more people who are going above our threshold? And we were getting complaints about drivers, food delivery who were saying that, hey, we are not doing any fraud. Why is my account banned and stuff like that? So we had to work with the product team who was launching that new feature. It was like, oh, okay, now that this new thing that's coming here, we had to increase our threshold. So we had all this kind of like back and forth with different teams who are also improving our product features. But because of all these changes, the fraud team had to be on our toes as well to kind of understand, hey, new features or new mechanisms, we had to change certain things as well. We have to work with different teams on those kind of stuff. So things like that, and of course, working with stakeholders when they're launching new features. I would say it's kind of more of a human behavior in the sense that when there's new features, the stakeholders will always say, hey, we want to have more new users. So they will like maybe dump a lot of incentives, be very loose with the user onboarding experience, stuff like that. Just come on, just get everybody as long as they are just an account. But we are always the wet blanket, like we are always the fraud team. We say, hey, you had a new 100 installs, but we realized that actually 50 of them are fraud because, you know, like you were too loose with your incentives. People were coming into just abusing our promotions. A lot of new accounts were existing users and stuff like that. So again, it's a bit of a dance. Kind of work with them. We want to ensure that at the end of the day, we want to ensure that Grab is a profitable business, right? Like we are not here to say, hey, your product sucks, but we are here to be the counterbalance. And I think it's good that actually Grab had this kind of different roles to ensure that the company is being very prudent with our spending as well. But sometimes we kind of feel like that we're the bad guy, like coming here and say, hey, sorry, you only had like 50 installs and stuff like that. So it is still an important role because we kind of are like the guardrails of a lot of product teams. And that sometimes actually can create a bit of friction here and there. But yeah, we kind of had to always be the bad guy. Yeah. So beyond working with the stakeholders, we also have to propose mechanisms to kind of reduce bad behavior. So like I mentioned, right, like if we were to detect fraud, a lot of times actually fraud has happened. So somebody has suffered. So rather than to hit that stage, right, a lot of times we actually have to propose certain things and say, hey, can we have a cap on the incentives for new users? Can we have a limit to say if there's an e-wallet transfer from A to B, it's a maximum amount so that we can't have two users who are doing 50 different transactions with each other, like e-wallet transfers, and getting an incentive for every transaction that they were actually doing. It doesn't make sense, right? Like they have already learned about that feature. We shouldn't be incentivizing them to just do transactions again and again. That doesn't make sense. So things like that, we have to work with the teams. Unfortunately, we can't always go through every product team's new launch, but we will try our best to whatever we can. And of course, last but not least, I think this is actually the most important part, which is to work with the risk audit teams on enforcement measures. Here I can go a bit deeper, although I think later I'll share a bit more. But the general idea here is that like we can detect certain things, but we can also kind of think about how we're going to enforce them. In particular, you can think about like if I understand that, hey, there's a high chance that this is not a syndicate fraud account. It's just a casual user or a really diligent driver who wants to earn a bit more money and he found a particular loophole. Maybe he just said, hey, come on, friend, can you just take this ride with me so I can complete my 10th ride and get that final incentive? Because I need to complete a certain number of rides. So we are actually always mindful, like should we be so strict? How is our enforcement mechanism going to be like? Are we going to send a warning? Are we going to send a hard ban? Are we just going to say, hey, we realize that this thing is not there's a bit of bad behavior, so we're not going to give you that incentive? Or are we going to like block all incentives? So there's actually a lot of layers that we can go about doing that. And again, we don't want to be so strict that the driver ends up saying, hey, come on, Grab is a very bad platform. It's always abusing us, saying that I'm fraud. I'm going to go to another platform instead. I'm going to be a driver on another competitor's platform. So it is a bit of a fine balance. And I always feel that the risk of people are actually in a very, very tough situation because they are the people that get a lot of complaints saying that, hey, why are you blocking my app? Why are you restricting this? Why can't I draw my money out? Come on, it doesn't make sense. And we are always the guy who say, oh, the data says so, I can't do anything. But of course, again, we have to kind of work as a team again. We don't want to be so strict and restrictive that in the end we are losing drivers or losing passengers because of our rules. So it is again a huge fine balance here that they're going to have to play. Okay. So some of the more deeper issues building on from the idea of machine learning solutions and analytic solutions. So just now I mentioned briefly, right? Like machine learning solutions can be a bit more robust than rules, because rules you kind of still have to think through the money trail, the intuitions. But in particular for fraud, the domain of fraud, explainability is quite important. I would say maybe now there's more advancements in terms of explainable models, but when I was at Grab, right, a lot of the models were a bit of a black box. It wasn't that our machine learning engineers couldn't explain. It is the nature of the model as it is. It was just probabilities changing here and there. But for particular regions, um, it is actually important for us to be able to explain why we are doing certain things, because there'll be certain regulatory bodies who say, hey, we are seeing certain things, and we might need to explain why certain things are happening. So this is a bit of a regulatory constraint. But I think it's also, in a way, kind of helps keep us grounded in a sense, because at the end of the day, when I was working at Grab, I realized that it's not just about me ensuring that Grab is a profitable business. We were really affecting people's livelihood. I had personally seen tickets that were saying that, hey, why do you block my account? I'm depending on Grab for my livelihood. Like, I need to bring food to the table and stuff like that. So I do feel that there was a bit of a social responsibility beyond just like dealing with numbers and feeling that I'm working in a tech company. So a lot of times it's actually about explaining why we see certain things. And actually having this rule-based kind of approach is a good counterbalance to all these very fancy, sophisticated blackboard models. And it kind of help us keep each other in check. Yeah. So that's the first point here. The other thing about machine learning models is that there's also always a need and a balance between the stability of the model and the scalability of the model. A lot of times, the rule-based approach is a lot more stable in that sense, because you can actually see the rules, you can see the thresholds. There will be times where maybe certain variables are changed and stuff like that, but at least things are a bit more within our control. Whereas sometimes machine learning models, because of certain changes that happen, it's a bit hard to kind of measure like model drift, why things are changing like that. Sometimes it is really just difficult because it's so many different knobs that it can change. Whereas for a rule-based approach, it's a bit more intuitive. We can say, hey, these rules is maybe getting a bit like the example that I had with the change in how our drivers were being sent to collect their meals and to deliver the meals. It was very intuitive because see, hey, the threshold is getting a bit too strict. Because of changes, we can change it and kind of test it when we have certain things that are changing here. And we could do and we could easily do a lot of sensitivity analysis and say, hey, now our threshold is at 35, maybe we could increase it to 50, increase it to 100, and we can see how it affects how many people we are detecting now with these different thresholds. And we can kind of play around with it. The crux of the situation here is that we were doing detection and not enforcement, because we don't want to like suddenly change and more people were getting blocked, right? And that is one of the issues, one of the things that we always balance between detection and enforcement as well. Yeah, and I'll go a bit more deeper there. So the other part here is also about the model in terms of detection coverage. It sounds a bit more abstract, but the example that I can give here, right, is that imagine you have a new model, and the model is very confident to say, hey, I have a 99% confidence that I can detect 10 users that are doing fraud. Yeah, so it's like, okay, it's very confident, but its coverage is very limited. So in a sense that, and of course, it actually costs time and money to kind of host all these models, having them on the cloud servers, kind of doing detections. But if it's only going to give us 10 new fraud accounts detection every day, or every month, or whatever period we have, it's not as useful in that sense. On the other hand, if the model is giving us a lot of coverage, meaning that it could easily detect tens of thousands of new accounts or new behavior, but it's not as confident, that also is a bit tricky in that sense. So in that sense, right, the idea of detection coverage can be a bit tricky. So actually, the machine learning engineers do have to grapple with this, and they have to take a bit more time to kind of put their model into production and kind of like test out certain things. Whereas usually it's a bit more easy to kind of move our needle when we're dealing with rule-based kind of stuff, because again, like I said, the thresholds, increase it a bit more, reduce it a bit more, and see how things happen. Okay. Going on a bit to be to focus more on the detection enforcement, because of some of the processes and resources required to kind of produce certain machine learning models and doing detection, right? It might be a bit tricky to kind of put them into production to do real-time detection. So there will be situations where we do kind of batch detection. Of course, this might not be as ideal because the fraud has happened and we're kind of like detecting them thereafter and saying that, hey, even though you said you had 10 rights that were completed and you're supposed to get a particular incentive, because we realized that 2 of them were considered fraudulent, we're not going to give you the incentive. Stuff like that. So sometimes machine learning models might hit issues of scalability because of just the amount of data that they need to consume and a lot of the stuff that's happening at the back of it. Rule-based usually is a bit more efficient. Of course, it depends on how your queries are being done as well. There are actually a lot of ways to kind of make your queries more efficient. So that's that balance as well. And of course, this last bit here, I definitely always want to stress is back to the idea of the balance between protecting our users from fraud, of course, protecting Grab from fraud as well, versus ensuring that we provide a positive user experience. So that balance is actually kind of tricky, which is why we always kind of have phased rollouts. So the recent example, right, like we won't do something that CrowdStrike did, where they launched like this new change and it affected so many computers. We always ensure that we kind of say, hey, we're just going to launch this new detection mechanism to 5%, 50%, so on and so forth. And even so, it is only detection. We would not trigger enforcement until we're very sure that the coverage is good, we're getting low false positives, or we are very confident about our detection rules and stuff. Yeah. So these are a lot of the issues that it's very domain specific. And I would say these are some of the learnings that I think is quite interesting from dealing with fraud. Okay. I'm on to my last bit here. So there were, if I remember correctly, I think there were 6 questions that were sent to me from Syria. So I'll cover them a bit more. I think I'm still good with my time. Okay, yeah. And of course, after this, definitely you guys can still ask me more questions. And I'll be sure to actually share the slides with Syria so that you guys can have access to the slides as well after this session. Okay. I'll quickly go through the questions. Okay. So this is the first question that I got. So where do you see this in 5 years? So I think it's like I see it as like where do I see myself in 5 years, or just in general. So for me, this is actually a common question. I think people always ask, right? Looking forward. I kind of have this approach where I kind of see myself that the first premise is I wouldn't be able to predict the future. I think it's very difficult, and I would just not give myself that false confidence. But I do see myself as having said, hey, I have certain expectations. I hope I can do certain things. And I see that it's a very data approach where, okay, I will take certain small experiments and see what kind of feedback I get from them. So an example would be, I was experimenting with dealing with like front-end engineering and stuff. Trying to understand, hey, does that work for me? And I think that can potentially be a lot of learnings for a lot of different people where they are saying, hey, is data analytics for me? Is machine learning engineering for me? Should I work in a different company and stuff like that? And I see that it's kind of like having a certain base and making small actions. And the feedback that you get from those actions, I'll realign my expectations thereafter and build my actions from there. I think it's a bit more less stressful to say, oh, in 5 years' time, I need to do certain things. And it also always keeps me on my toes to be always thinking about how I learn certain stuff. Yeah. So these are the things that I'm looking at, kind of like thinking about scaling my operations to work with maybe more freelancers. Also thinking about productionizing my services, maybe in that sense, and still continuing some of the side projects that I have so that I can maybe see how I can maybe build certain things that's valuable to somebody in the society that could pay me for it. Yeah. So this is just some like my own quick sharings here. So the next question that I have here is, how do you think someone can improve their skills? And I think this is actually a very, very important question because I think in tech and particular data, things are always changing. So I think this is actually a very, very important question that everybody should ask themselves. And this is kind of my approach. It's kind of similar to what I had just now, but of course this is in particular to skills. So I would say get feedback. And I think feedback can come in many ways. These are just some of the ways that I'm thinking about. But from a first principle perspective, is really to get feedback. Get feedback, you can, at least from me, I see in these ways. Firstly, is to perform the skill. So if you want like to improve your skills in, let's say, machine learning, perform the skill. If you want to improve your skills in dashboarding, just do a lot of dashboards. Because nothing can beat reading about more dashboards. Of course, you can read, you should still learn, but I think it's really about performing the skill, performing the task you want to be better in. And you yourself would kind of have a sense, hey, as in, maybe my dashboard isn't that beautiful, or maybe my dashboard isn't that performant. It's very slow. Why? So, if possible, I understand that it's not always possible, but if possible, get feedback from people who you feel would directly be impacted by that skill. So, an example would be, say, if you want to improve my dashboarding skills, after you have created a dashboard, share with your peers, maybe fellow data analysts, or share with any product managers that you know and ask them for feedback. They would actually say, hey, it's good, it's bad, or like, hey, I don't understand this. Maybe can you write some, give me a glossary or give me some kind of explanation. Can you add a title here and there? Of course, I would say, to be fair, you should be critical as well about the feedback that you got, because it is still feedback that you have to consume at the end of the day. But I think it's always good to have that back and forth and understand, hey, maybe this thing does make sense, or maybe I should add certain things, or maybe I'm too focused on the aesthetics and people don't really understand what my dashboard is kind of showing. So I think it's very important to actually really perform the skill that you want to be good in and get feedback. The best situation is you can get both. But I understand that sometimes it's difficult because not everybody can access to people who are in the domain. But I feel that if it's possible, this is the best way. And of course, naturally, don't stop at the first time you're doing the task. Always iterate and always try to see how you can improve your approach based on the feedback that you get. Yeah. So I do feel it's quite important to be it, I don't know, reach out to professors if you're still in school, or reach out to peers, have a community of people who are working with you together to kind of bounce ideas. And of course, different people have different angles to certain things. So sometimes you can maybe even reach a stage where you agree to disagree. But at least it's always good to understand, hey, I got this feedback before. And maybe once you get the same feedback enough, you realize, hey, maybe I'm the one that's being a bit stubborn. Maybe I'm the one that's missing something, and maybe I should consider again, like, what's the mistake here that I'm making. Yeah. So I think feedback is important. Being open about receiving the feedback. Okay. So there's another question here. So, how important is data analytics in your business domain? I kind of so feel free to chime in as well if I kind of misunderstood the question here. For me here, I kind of see it as like how important I feel data analytics is in just in general, in that sense. Okay. And this is my take on this. So I was pretty fortunate to be able to work in at least 2 different domains, and now as a freelancer, dealing with different domains is kind of like what I have to do. So in Carousel, I was doing digital marketing. At Grab, I was dealing with fraud. So I feel that at the end of the day, I do agree that not every industry can benefit as much from data as some industries. And how I assess my clients to understand, to see, hey, can I be useful to my clients? Because I don't want to be coming in and being the fraudster that just like takes money from my client and not producing value, right? So for me, it's actually very important to assess how I can apply my analytic skills to help my clients, which is at the end of the day, is just how I see whether analytics can be useful to that domain. And for me, of course, the main idea is that the domain has to have data. And when I'm reviewing how data analytics has progressed, right, I realized that actually one key thing is actually the evolution of how data is being captured, how data is being processed. So for people who know, like, there's a huge boom in sports analytics in the past, I think 10 years. Of course, different sports have different kind of angles, right? But I do see that it's a lot of improvements with video analytics, how data points are being captured, how they're having IoTs on like the balls, on like the shoe wear, like from different stadiums and stuff like that. And a lot of these new data that can be captured kind of informs the domain on like what are new things you can actually work with. So I do feel that at the end of the day, like at the end of the day, it's still about having data, but also about understanding, hey, how the data can be applied to that domain. So there will be certain industries that maybe data is not so prevalent. So I think that is kind of a bit of a no choice, right? Like, it's whatever the domain has. But usually how I go about is to assess whether the domain is where data can help that domain is really whether there's data available or not. Okay. Yeah. So and I think this last bit here I would emphasize also is that domain knowledge is important as well. I think my personal experience is that when I had to deal with fraud, it wasn't just me saying, oh, okay, whatever was being taught to me, I'll just apply. I really had to get vested into thinking from a fraudster's perspective, learn a lot about cybersecurity as well, so that I can say, hey, if I have this data point, maybe I could detect this kind of fraudulent behavior that I learned from my peers and stuff. So that's how I see this question. Okay. I think this is also one question that a lot of people are worried about. So what do you think about the future of data analytics when Gen AI becomes more prevalent? And I think this is actually something that a lot of people are worried about. And I have this one liner here, the first line here. I feel that having an analytical mind is more important than having technical skills. And the analogy that I worked with is kind of thinking about how things has progressed again from the past. And I think history is always interesting. When you kind of review how things are happening in the past, there's a higher chance you can kind of say, hey, how things will move forward in the future. So what I saw was like, just like the internet. Um, I'm not. I think most of you guys are pretty young. I'm a bit older, so I've gone through the stage where like internet just boomed, and there were a lot of things where people say, "Oh, with the internet, you will not need any more engineers." And of course, like right now we're living in the age where engineers are still the de facto alpha people in the tech world, right? In the sense that like people would say that, oh, like with the internet, you can just Google everything. You don't need to know programming. You don't know whatever, but that's not true. And I feel that it's similar with Gen AI. And to me, I kind of see Gen AI as like internet on steroids. In the sense that like right now, it's actually much easier for me to kind of say, hey, I'm not very familiar with JavaScript, but I know certain things that can be done. I can just quickly use Gen AI and say, oh, okay, I can quickly prototype a front end, produce something for my client. My core value is still analytics. But because I know what I can do with analytics, I know what could be done with front end work with a bit of Gen AI, I could combine them very easily. And I feel that that was something similar that the internet gave a particular generation. And I feel that Gen AI is doing the same thing for our generation, or at least this current generation, moving forward, thinking how the future will be like. So definitely it's very easy, much easier now to learn, research, and execute about the hows. How do I perform gradient, like how do I use gradient boosting? How do I do certain detections? How do I use network graphs? But I think it's more important to understand the whys. Like, why am I doing this? Why should I be detecting fraudulent behavior of this particular feature versus the other feature? A lot of times it could be thinking through the domain about understanding what's the value of a particular how and what's the impact. So I do feel that actually right now, right, there's still an issue with hallucinations with Gen AI. And I have had instances where I realized that because I had a bit of knowledge of the particular domain that I was dealing with, I could ask more specific questions to reduce the odds of a Gen AI hallucination. As compared to a person that's totally fresh from that domain, if he's just asking simple questions, he might easily get misled by Gen AI. So of course, again, none of us can predict the future with 100% certainty. But I do feel that moving forward, I think having an analytical mind is more important than having technical skills because it's very easy. But right now, I think it's just easy to say, hey, I need to extract data from BigQuery. Can you give me a SQL that does this? It comes out pretty easily. Of course, if you have the SQL skills, it's much easier as well. You could maybe even test certain things to ensure that, hey, this SQL isn't as efficient. It gives me the correct answer, but it's not as efficient. So, and stuff like that. So I do feel that rather than saying that like Gen AI might affect the industry in a negative way, I think I do see it as an enabling tool as well. But of course, I need to be able to know how to use the tool. So I feel that the worry shouldn't be about it replacing data analysts or data analytics. I think it's more about how it complements and how we can use Gen AI as well in our workflows. So that's how I see the future of data analytics with Gen AI. Okay. So this is another interesting question. So what are the key challenges of being a data analyst? I think for me, I do see a lot of people because when you want to enter the industry, you're always thinking, hey, how much SQL should I learn? How many lead code questions should I finish? How many HackerRank questions should I finish so that I can pass my interview test and stuff like that? But I feel actually at the end of the day, getting into the industry is just getting yourself like one foot one foot across the door. I think at the end of the day, it's always about providing value, right? And I think in particular, these parts, so I actually like to add like sometimes unreasonable amount of time and money. In the sense that it's at the end of the day, you can have the best model, you can have the best data quality, but if it's not applying to the correct domain or it's not applying to the correct project for your domain, it's not providing value. And if you're not providing value, there is the high chance that you get laid off or like your team is not deemed as valuable and stuff like that. So I think that is the difficult part. In particular, if you're dealing with specific domains, you really need to appreciate what your domain is dealing with, what value your domain is trying to create, And from there on, thinking, hey, okay, so this is what I'm looking at. How can data add value to that domain? And how can I use data to kind of measure the increase in the value from data? Yeah. So I think that is the most difficult question that I face nowadays. Because I feel, again, going back to the question before, with Gen AI, it is easier to learn technical skills to a certain level. And I think nowadays there's a lot of materials out there on YouTube and whatever. I don't think it's difficult to learn a lot of things, but I think it's really difficult to define value. I think that's the part that I'm still kind of like trying to be better at. Okay. So key challenges. I think almost my last. I think this is the last question. And again, feel free to answer more questions as well. So this last question here. As a data analyst expert, what do you recommend us and the future analysts do to learn, be ahead of the curve? I think this is a good summary point. I think I've kind of alluded to this point across within my presentation here and there. But I like to think from first principles. I won't go too deep into it. Elon Musk had a good article, I think, that where he was sharing about first principles. I'm not an Elon Musk hater or lover. I just feel that first principles is actually a very good way of thinking about stuff. But I won't go too deep into it because that will be another long session. I do feel that something that's a bit more applicable to data analysts is to really think about what is this unique portfolio of skills that you can have. And of course, how you can showcase them. And again, more importantly, is what kind of value your this portfolio of skills can create. Yeah. So an example, right, is that for me, I came from an econs background. So naturally, I always have this imposter syndrome where is my coding better than computer science majors? Is my statistics better than stats majors or math majors? But I realized that rather than harping on my weaknesses, I do feel that maybe I'm a bit more sensitive to business outcomes. I'm a bit more mindful of what is the economic impact of my work. And I can just kind of build from there. So I think maybe I'm a bit more okay with presentations as compared to some of the computer scientists. And I don't think it's a good or bad thing. I think it's just knowing about yourself, knowing where you can apply the least amount of effort to get maximum amount of impact. And I think everybody is unique to that level. So in that sense, it's kind of like a unfortunate thing is in the sense that you always have to learn new things, which is I think I like one of the earlier questions as well. But I think it's important to really think from your perspective. Hey, am I gonna be a machine learning expert? Am I gonna be a data analyst that's very proficient in, let's say, user journey analytics? Am I strong in, I don't know, churn analysis or whatever, so on and so forth. So I think this is something that everybody should think about from themselves, because I think everybody has their own preferences as well. Like I tried to do a lot of things as well, but in the end I kind of converged to a certain position where I feel that I'm most comfortable with where I am right now. So I think this is something that is something that I think a lot of people should think about. Again, looking at what kind of portfolio of skill sets you guys would want to have, and what kind of value your this portfolio of skills can actually provide to society and the people around you. Yeah. So I think this is my last question. Okay, yeah. So just some stuff if you guys are interested. And again, I'll share these slides with you. So no worries if you guys are interested and you guys feel that you all can't get certain things previously. That's all from me. Yeah.
It was a great presentation, Cliff. And as a personal feedback, I think that you were really passionate about discussing all your insights with us. And I liked how it was very insightful and was a saturated version of your life experiences in the industry. So that's as we are running out of time. So let us just come to an end. And thank you so much for being a part of this session and taking time out of your busy schedule. You really presented an ocean of knowledge that we all can really dive deep into. And I think that it is a great opportunity for the young aspirants of this industry, as they would have the knowledge of this issue beforehand. And coming from you, I think it would be of great value. And I really appreciate all the participants who were attending the event. And I hope you all have a good day. And Cliff, I hope you have a great weekend. And for the people in India, have a wonderful weekend. And the attendees from Canada, have a good night as it is very late for you. And I thank you for your coordination and cooperation. Thank you so much.
Thank you. Thank you.